Did you know? How does calcitriol regulate calcium levels in the body? Calcitriol, the active form of vitamin D, 1,25-dihydroxyvitamin D3, plays a critical role in regulating calcium levels in the body by maintaining a delicate balance between calcium absorption, storage, and excretion. Its primary function is to ensure sufficient calcium is available in the blood for vital physiological processes such as bone mineralization, muscle contraction, nerve transmission, and blood clotting. Here's how calcitriol works. 1. Enhancing calcium absorption in the intestines. Calcitriol increases the absorption of dietary calcium in the small intestine, particularly in the duodenum. It does this by stimulating the production of calcium-binding proteins, e.g., calbindin, in the intestinal cells, increasing the activity of calcium channels and transporters, allowing calcium to move efficiently from the intestinal lumen into the bloodstream. This process ensures that dietary calcium is effectively utilized, reducing the risk of calcium deficiency. 2. Regulating calcium release from bones. When blood calcium levels are low, calcitriol helps mobilize calcium from bone stores. It works in conjunction with parathyroid hormone, PTH, to stimulate osteoclast activity, the cells responsible for breaking down bone tissue and releasing calcium into the blood. While this mechanism ensures short-term calcium homeostasis, excessive reliance on bone calcium can weaken bones over time. 3. Reducing calcium excretion by the kidneys. Calcitriol acts on the kidneys to minimize calcium loss in urine. It enhances the reabsorption of calcium in the renal tubules, ensuring that more calcium is retained in the bloodstream rather than being excreted. This process works synergistically with PTH to conserve calcium, especially during periods of dietary insufficiency. 4. Synergy with parathyroid hormone, PTH. Calcitriol and PTH work together to regulate blood calcium levels. When blood calcium levels drop, the parathyroid glands secrete PTH. PTH stimulates the kidneys to convert 25-hydroxyvitamin D into calcitriol. Calcitriol then increases calcium absorption in the intestines, mobilizes calcium from bones, and reduces renal calcium excretion, restoring calcium levels to normal. Feedback mechanism. Calcitriol levels are tightly regulated through a feedback loop. High blood calcium levels inhibit PTH secretion, which in turn reduces calcitriol production. Similarly, high calcitriol levels suppress PTH release and downregulate the conversion of vitamin D to its active form, preventing hypercalcemia. In conclusion, calcitriol is essential for maintaining calcium balance in the body. By facilitating calcium absorption, reducing its excretion, and regulating its release from bones, calcitriol ensures that calcium levels remain within a narrow range to support critical physiological functions.